Yo, sorry. Yo, what's up, everyone? Welcome back. We're in week 8. Looks like we're somehow going to have 10 weeks in this quarter. I don't even know how that's possible. But I think I'm going to make more end of quarter announcements next time. We're pretty much just crushing it. But we have around 2 weeks left, and then we're in the final stretch of this crazy year. Anyway, I think this is going to be a great lesson. I'm pretty excited about it. And we're talking about exponents again. We're doing exponents for this lesson and then next week as well. And our real goal, we zoom in, is to first figure out how we can simplify things. Like you can look on further down the worksheet at what we're building towards. But what we really need to figure out is what all kinds of exponents mean, right? So very quickly, a normal exponent is just like a number, right? We can say 8 squared. We know that that means 8 times 8, right? And that's a positive exponent. Something that we're going to do next is a fraction exponent, okay? So that's going to change the number. And what this is just a square root, actually. So that's what we're going to learn. But what we're talking about today is what we do if we see a negative exponent. And it's actually going to be pretty easy and pretty interesting once we get to the next 2 examples. But for this first example, I'm just going to show you exactly how to do it. And it's just going to take 1 second. If you ever see a negative exponent, think that you want to get rid of that. That's something that you want to simplify. And a negative exponent just means that this number, instead of being on the top of a fraction, is going to be its reciprocal, or we flip the number. So instead of seeing 8 negative 3, we know that that means it's that over 1, right? Every number is over 1. But if we flip it, we can make that negative 3 positive 3. So 1 over 8 cubed. So these are the same thing. If you see 8 to the negative 3, that means it's 8 cubed, but not on the top of a fraction, but on the bottom of a fraction, okay? And then you should actually solve this. So 8 cubed is a pretty big number, 512, okay? So 1 over 512. And we have talked about this, I'm pretty sure. I'm kind of drawing a blank. We'll get back to the graphing to connect it, but I think we have talked about this a little bit, okay? So think that if this exponent is getting bigger and bigger, so negative 4, negative 5, etc., all that's happening is the number is getting closer to 0 because the bottom of this fraction is getting bigger, right? So think that 8, just as a side example, because this is mostly kind of a logic lesson, 8 to the negative 4 is going to be 8 times 8 times 8 times 8, but on the bottom of a fraction, okay? And we know that the bigger the bottom of a fraction is, the smaller the number is, and the closer it is to 0, okay? So that's the big idea. And let's talk about how that works and why that works. So what we were doing last time was simplifying exponents, right, or exponential expressions. And if we have something like this, we have the same base. We see 5 squared divided by 5 to the 6. The rule that we learned is that we can simplify this by just taking the top exponents and subtracting them, right? Crap, I just showed it, the answer. I mean, it doesn't matter, but this is going to simplify to 5 to the 2 minus 6, which is just the same thing as 5 to the negative 4, okay? So that's the answer, but it's a negative exponent, right? So I didn't give you any of these intentionally last time, unless I made a mistake on the practice problems. But if the top of your fraction has less 5s, then you're going to end up with a negative exponent, right? And if we're going to tie it back to this example, and I think this is really interesting, we want to know, why is this the same thing as 1 over 5 to the 4, right? Because that's what we're saying. 5 to the negative 4 power is just a flipped number. And if we're looking here, let's think that 5 squared is just 5 times 5. And 5 to the 6 is just 5 times 5, 6 times, right? And if it was the other way, right, if it was 5 to the 6 on the top and 5 squared on the bottom, we know that we could cross out and that would show how many are left. And we can do the exact same thing here, okay? Those 5s cross out and all that's left is 1 over 4 5s on the bottom, which is the same thing as 1 over 5 to the 4th. I hope you can see it, but I think that's really, really fascinating. So if the bottom has more 5s, that means that the bottom is going to have our exponent, okay? Very, very cool. So 5 to the 4 is 625. So we can simplify this to 1 over 625. And this is perfectly fine. Fractions are actually better in Algebra 2, I think I try to say, compared to decimals, but this is a good answer. And that's pretty much the entire lesson. We are going to refine and make it a little harder, but that's the gist of it. This is another example I wanted to talk about that kind of highlights what this is all about. What's interesting here is this is pretty easy. So we see 3 to the 4th times 3 to the negative 7. All you have to do is add the top numbers, right? This is a question that you could have solved yesterday because we know that same base exponents, we can add together the top numbers. So the top here is 4 minus 7, which is the same thing as 3 to the negative 3, right? So this is going to end up being 1 over 3 to the 3rd, which is the same thing as 1 over 27, right? So that's going to be our answer. But now that we have kind of mastered more of these exponents, I want to talk about how you could simplify this and how it all kind of ties together in a beautiful way. This is 3 to the 4 times 3 to the negative 7. But if we know that 3 to the negative 7 is really just 1 over 3 to the 7, we can put that on the bottom of a fraction. So we can actually turn this multiplication question into a fraction question, right? Negative exponent means it's on the bottom. This, I mean, we're still going to get the same answer, right? I'm just trying to show it to you in multiple ways. Think that there's 3 more 3's on the bottom. So this is going to turn into 1 over 3 to the 3rd. So yeah, hopefully you find that really cool. And yeah. One final note on the number ones. Basically, if you ever see a negative exponent, your instinct from now on should be to try to get rid of it. So this is something that is ugly and bad. It says 1 divided by 10 to the negative 3. But think that the same rule applies. Okay, and this gets kind of it's weird but easy. But if you wanted to flip this negative exponent, it's already on the bottom of this fraction. So you just bring it to the top. Okay, so a negative exponent just means that this number is going to be flipped on what part of the fraction it's in. If there's no fraction, you create one with 1 on the top. So something like this is actually just a really roundabout way of saying 1,000. Because if we flip that negative to the top of a fraction, it just becomes 10 cubed on the top over 1. Okay, so when you're doing these, never circle a negative exponent. Always flip a negative exponent. Now we're going to do some of these with variables, which I think is honestly easier. First, we have x over x to the 6. And again, there's just a single x on the top. So if it helps you, you can put the implied number 1 there. And there's a few ways to approach this. We know it's x to the 1 minus 6. Just think that there's 1x on the top and 6x's on the bottom. You could use the math to get x to the negative 5, but we don't want to circle this negative 5. So we're going to flip it to the bottom of this fraction. So that's the answer. And you wouldn't have to even do this if you kind of recognize that what's happening here is there's 1x on the top and 6x's on the bottom. One of them cancels out, leaving one on the top and just the number one on the top, and then 5x's on the bottom. So this is how you want to simplify. I did that quick because a lot of these are pretty simple, or at least these kind of single variable ones. Here we have x to the negative 12 times x to the 8, and we're just going to add their top numbers together. We'll get x to the negative 4, and then we flip that, so we get 1 over x to the 4th. The rest of these are not anything new, so long as you can do a few of these at the same time, and that part doesn't trick you. So all you're dealing with here, and this is maybe even stuff that you saw in previous math classes, I think that's possible, is let's simplify a bunch of exponents together, right? And in my opinion, this isn't as real world practical. To see x, y, and z is not something that you could connect to like anything in the real world yet. But we can still kind of mess around with it. So if I'm seeing this first one, I see x to the 9 times y to the negative 1 times x to the negative 3 times y to the negative 5. And this is a common situation where you have to combine the like terms or do math related to the x's and then the y's, right? What I always try to say is that if something is confusing you in a question, ignore it and do what you can do. So we see that we had these parts. I don't know what I'm doing exactly, but I think you hopefully see what I'm saying. Let's combine x to the 9 and x to the negative 3, right? So those two together become 9 minus 3. And then we just do the same thing for y, which I think is really simple. So we're just applying the rules from last time with multiple variables at the same time. Here, we get x to the 6. And then here we get y to the negative 1 minus 5, or y to the negative 6. Now this is the answer, but it's not perfect because we don't want to circle a negative exponent. Think that a negative exponent is less clean than turning it into a fraction. Okay, so when you have a bunch of these in a row, basically whatever is positive stays on the top of the fraction, but then whatever is negative is going to go to the bottom. So we flipped that negative 6 to 6. We just put that on the bottom. Let's look at this one, which is a fraction example. And you might start becoming really good at this and just kind of looking, right, to see that we see x cubed and x6. X cubed is going to remain on the bottom and y 14 on the top. That's me doing it in my head, but let's kind of talk about how I did it. If you want to look at them one at a time, that's our best approach. It's kind of being wonky. I don't know why. My paper. But yeah, the first one here is x to the 3 minus 6, if you wanted to put it in a single one. And then the second one would be y 10 minus negative 4. So what's important here is to think that y to the negative 4 on the bottom is actually just y to the 4 on the top, right? You can flip it to the top and think you have y to the 10 times y to the 4. But if you ever get really stuck, you can always just do the math, right? If you see a fraction, it's the top number minus the bottom number. So 3 minus 6 gives me x to the negative 3. And then 10 minus negative 4 is going to be 14, or y to the 14th. This isn't our final answer because we need to flip the x to the bottom. So y to the 14 and then x cubed. And again, you don't have to do it this way if you can start visualizing, because what I was trying to say in the beginning was that if you just look at these x's, you can tell that there's 3 x's on the bottom, right? And if you start getting really good at it, you see this and you can say, oh, there's actually no y's on the bottom. there's 10 y's here and 4 more y's, so 14 y's on the top. Let's do number 10 because I think we're kind of crushing it, and I think this concept must make sense. This is like a challenge. This is like the hardest it could possibly be. First, we have all 3 variables, and then we also have an exponent of an exponent, or this 4 on the outside. But we're going to ignore that at first and tackle something that we know how to do. So even with 3 variables, my objective is do them separately. So if I'm looking for my x's, I'm going to do this one the fast way. And if the fast way is confusing you, don't overthink it and go slow. But if I'm looking just at my x's here, x to the negative 12 on the top means x to the 12 on the bottom. So I'm seeing x to the 14 on the bottom of a fraction. And if I'm trying to do it, in a speedy manner, I can start writing it like this. That's excuse me. That's my x's. With my y's, I see y to the 4 on the top and y to the negative 2 on the bottom. Think that we can bring this to the top. So we're going to have 6 y's on the top. And then with z, we see z to the negative 6 on the top here and z to the 4 on the bottom. We can flip that negative to the bottom here, and there's going to be 10 z's on the bottom. So now we simplified all of the inside. It looks clean. And we now have an exponent of an exponent. And just remember that in this case, you don't add, but you multiply that 4 to every number. Sorry, my voice has been so raspy. I have no idea why, honestly. It's pretty earlier than usual, but I don't know. I think this was a good lesson. I think it went quick too. And I hope it makes sense. So that's that. And your questions will be similar. So keep up the good work.